When you look up at the night sky, you see stars, billions of them, each a sun burning in the vast darkness. But stars aren't alone. Many have families of planets circling them, just like our sun has Earth and its neighbors. These solar systems are scattered throughout the galaxy, each with planets that are wildly diverse. Some are giant gas worlds, others are rocky and small, some scorched by their star, others frozen in the dark. We've discovered thousands of these exoplanets, planets outside our solar system. It makes you wonder, how many worlds are out there? What are they like? We used to think a planet needed a star, a gravitational anchor, a source of light and heat. Our own Earth depends on the sun for life, weather, and the rhythm of day and night. So, the idea of a planet without a star sounds strange, impossible even. But the universe is full of surprises. Scientists have realized not all planets are tied to a star. Some worlds drift alone, not circling any sun, with no system to call home. They are wanderers, moving silently through the immense empty space between the stars. These hidden worlds are changing our understanding of what a planet can be. They challenge our ideas of where planets might exist. The cosmos is not just a playground of stars, but of countless unseen worlds. These lonely planets are out there, waiting to be discovered. They remind us that the universe is far stranger than we ever imagined, and their story is just beginning. These lonely worlds are called rogue planets, also known as orphan planets or interstellar nomads. I like the term rogue. It gives them a sense of independence. These planets have been untethered from any star, drifting through the Milky Way on their own. They don't follow neat orbits. They travel in straight lines through the cosmic darkness. Imagine Earth without the sun, a sky forever black, no sunrise, no warmth, just a frozen, silent world. That's the likely fate of a rogue planet. Perpetual night and unimaginable cold. But these aren't just tiny rocks. Some are as massive as Jupiter, or even larger. Others might be Earth-sized or smaller, but all are complete worlds, with cores, mantles, and maybe even atmospheres. The only difference, they have no star to call their own. Rogue planets challenge our very definition of a planet. For a long time we thought a planet had to orbit a star. But these cosmic loners show us that planets can exist in ways we never imagined. A planet is a world, shaped by its own gravity, whether or not it has a sun. The universe is more complex than we thought. Rogue planets are the ultimate cosmic outsiders. They remind us that the galaxy is full of surprises, and they're rewriting the rules of what it means to be a planet. If rogue planets float in darkness, how do we find them? You can't just point a telescope. They don't shine, and there's no nearby star to light them up. It's like searching for a black bowling ball in a pitch-black room. But scientists have a clever trick: gravitational microlensing. This technique uses gravity itself as a magnifying glass, a concept from Einstein's theory of general relativity. Massive objects like planets warp the fabric of space-time, bending the path of light from distant stars. When a rogue planet drifts in front of a distant star, its gravity bends and focuses the star's light, making it appear to brighten for a short time. This brief brightening is the signal, a clue that an unseen object has passed by. By measuring how long the star brightens, and by how much, astronomers can estimate the mass of the object. Short events, lasting hours or days, often mean a planet-mass object. It's painstaking work, monitoring millions of stars to catch these rare, fleeting events, but it works. This is how we've confirmed the existence of rogue planets, catching their ghostly shadows as they pass in front of the cosmic wallpaper. Each detection is a glimpse into the hidden population of our galaxy. These methods are opening a new window into the dark, and with every discovery, we learn more about the universe's most elusive worlds. The hunt for rogue planets is just beginning, and the darkness is full of secrets. Where do these wandering worlds come from? One theory: rogue planets start in normal solar systems, forming from the same disk of gas and dust as other planets. But early solar systems are chaotic. Planets jostle for position, and some get too close to giants like Jupiter. A close encounter can fling a smaller planet out of the system, turning it into a cosmic exile. Another theory: some rogue planets form alone, collapsing from cold clouds of gas and dust, never igniting as stars. Ejected planets might resemble those in their home systems, while isolated ones could be more like failed stars. Studying these rogues reveals the wild processes that shape planets. They show us both the chaos of crowded systems and the loneliness of deep space. Each rogue planet is a clue to the galaxy's hidden history. How many rogue planets are out there? The numbers are staggering. Some studies suggest there could be dozens, even hundreds of rogue planets for every star in the Milky Way. With hundreds of billions of stars, that means trillions of hidden worlds drifting through our galaxy. The most common type of planet may not orbit a star at all. The galaxy is teeming with these dark, lonely worlds, possibly outnumbering stars by a huge margin. The space between stars, once thought empty, might be filled with planets. Their combined mass could even affect the galaxy's structure and gravity. We've been counting stars, but missing the vast, dark population of worlds between them. If you traveled from our sun to the nearest star, you'd likely pass dozens of unseen, frozen planets. The galaxy isn't a collection of isolated islands. It's a cosmic soup, thick with stars, gas, dust, and countless hidden worlds. Rogue planets are everywhere, waiting to be found. And they're changing how we see our place in the universe. Why do we care about these dark, cold worlds? Rogue planets are keys to understanding how planetary systems form and evolve. Each one is a fossil from a chaotic past, a clue to the violence of young solar systems. There's also a tantalizing question. Could a rogue planet support life? With no star, the surface would freeze, but internal heat and a thick atmosphere might keep water liquid below. Life could exist, powered by chemical energy, like creatures around Earth's deep-sea vents. It's a long shot, but the universe has surprised us before. Studying rogue planets expands our sense of what's possible. Every discovery is a new clue in the story of our galaxy. We've just begun to explore the universe of rogue planets. We know they're out there, but we don't know how many or what they're really like. Gravitational microlensing lets us find them, but only for a fleeting moment. We want to go further, to study their atmospheres, their temperatures, their secrets. New telescopes, like NASA's Nancy Grace Roman Space Telescope, will revolutionize the hunt, finding hundreds or thousands of rogue planets, even Earth-sized ones. The ultimate dream, to send a probe to one of these dark worlds and see it up close. What would we find? A frozen rock, a gas giant, or a hidden ocean teeming with life? Rogue planets are the next great frontier. They remind us that the universe is full of mysteries, waiting in the dark, and every discovery brings us closer to understanding our place in the cosmos.